Good morning and welcome back, Course 1. I'm back here with another exciting lesson. Today we're going to take a look at Lesson 96, which includes both functions and graphing functions. You'll find this on page 497 in your book. All right, so talking about functions today. So we're talking about functions. We're talking about a certain relationship between two numbers. So let's take a look at example 1. Example 1 says find the rule for this function. So we have L and M. When I input 5, the output is 20. So what happened to 5 to get 20? Okay, so there are a couple of things that I could do. 5 times 4 is 20, or 5 plus 15 is 20. All right? But we know it's increasing. Well, which rule is it? Is it times 4 or is it plus 15? In order to discover the answer to that, we need to look at the other numbers. Okay, so 7, and we don't know what comes out. 10 goes in, and 25 comes out, and 15 goes in, and 30 comes out. All right, so if we look at the other numbers in this function, is 10 times 4, will that give me 25? No. So I know that it can't be this answer. 10 plus 15, will that work? Sure enough. 10 plus 15 is 25. Will it work here? 15 plus 15 is 30. Yes, indeed. So I know that the rule for this function is plus 15. So I can apply that here, and 7 plus 15 is 22. So the answer is 22. Now let's take a look at example 2. Example 2 says find the missing number in this function. All right, so now it has a table set on its side, which is fine. It doesn't make a difference to us. And in the first box, we have x, and then we have 3x minus 2. So it's already telling us what's happening. We're taking x and multiplying it by 3, and then subtracting 2. So if I start with 2, if x is equal to 2, 3 times 2 is 6. 6 minus 2 is 4. If I have 3, x is 3, so 3 times 3 is 9. 9 minus 2 is 7. Okay, so if I have 4, what will this be? Well, I plug 4 in for x. 3 times 4 is 12. 12 minus 2 is 10. So the solution there is 10. Now, if I'm graphing these functions, okay, here's what I would do. I'd make a little graph. Okay. And here's 1, 2, 3, 4. I'm gonna graph this one over here. Okay? And I'm gonna go up by 2s. 2, 4, 6, 8, 10. And I can change the scale, but I have to be consistent. Okay, so the scale going this way goes up by 1. Scale going this way goes up by 2s. The high number in this is 10. And the high number here is 4. That's why I chose the two different scales. All right, so now to graph this, I got to find the point here, which would be 2, 4. So point 2, 4 is this first point. The second one is 3, 7. 1, 2, 3, and then up to 7, which comes between 8 and 6. Okay, so 3, 7, that would be right there. And then 4, 10, 4, and 10. Now, what do you notice about these points? They should form a straight line. Okay? Every function should form a straight line here, if it's a linear function, and we'll get into other things later. All right, so now I want you to do letter C. So pause the video right now and do letter C. All right, welcome back. let's take a look at C. Okay. May have drawn that a little bit too big, but that's okay. So on top we have x, and on the bottom we have 3x plus 1. Okay, and our different values for x are 3, 6, and 8. 3, 6, 8. And so what would our values down here be? Well, if I plug a 3 in here, 3 times 3 is 9. 9 plus 1 is 10. Plug a 6 in. 3 times 6 is 18. 18 plus 1 is 19. 3 times 8, 24. 24 plus 1 is 25. And now I could graph those. The scale on the bottom, I'm going to go by 2s because the highest value is 8. So 2, 4, 6, 8. Going up the side, I'm going to go by 5s because the highest value is 25. So 5, 10, 15, 20, and 25. Okay? So the first one is 0.3, and 3 would come between 2 and 4. So I'm going to go midway between, and I'm going all the way up to 10. So the first point would be 0.310. Second point, 619. 6, and just below 20 is 19. And then 825. 8 and 25. Again, you should see these are linear functions, so they'll form a straight line. That's it for this lesson. If you have any questions, please call, text, email, or join me online between 9 and 10 o'clock tomorrow morning. Have a fantastic day.